So what we're going to look at in this video is we're going to focus on some special types of angles that are created with parallel lines when parallel lines are intersected by what's called a transversal. So what I want you to first do is I want you to pause the video and take a look at the launch activity. So go ahead and pause the video now and try to do the launch. So in the launch activity, you have a picture of these ladders and platforms that are going up a building. It's a fire escape. And the question asks, when you're looking at these pictures, which angles look congruent? And do you notice anything about the ladders and the platforms? And so a few things that you might notice is the ladders are parallel. So ladders are parallel. It appears that you have some congruent angles. Maybe I'm going to highlight on the picture like this angle right here and this angle right here look like they might be congruent. Maybe this angle looks like it might be congruent to those two angles as well. Then you have some obtuse angles that look like they might be congruent here, here, here. Those angles look like they might be congruent. Now, how would we identify these angles as congruent? We would need to get a very large protractor and go to this building and climb up the ladders and start measuring those. So what we're going to do, since that's not realistic, is we're going to look at an activity, an investigation, and we're going to try to figure out some things about angles. So the first thing that we need to define are the different types of angles that we're going to talk about. So first, you have corresponding angles. Okay, so an example of a corresponding angle would be angle 1 and angle 5. All right, and then another corresponding angle might be well, not might be, but would be, for instance, 4 and 8. Okay. So we will define corresponding angles here in just a minute. The second type of angle that we're going to look at is called an alternate interior angle. And in this picture, angles 3 and angle 6 are alternate interior angles. You might also find, being an alternate interior angle, 4 and 5 are alternate interior angles. And again, we'll define these in just a minute using the Desmos activity. The third and final type of angle that we're going to look at today are called alternate exterior angles. And in this picture that we have over here, angle 2 and angle 7 would be alternate exterior angles. And you'd also have angle 1 and angle 8 would be alternate exterior angles. So when we have parallel lines that are cut by a transversal is a line that intersects two parallel lines. Okay, so that line right there is the transversal. There are some special relationships among the angles. So what we're going to do is we're going to walk through an activity on Desmos that you can and should do this activity on your own. So if you have not done it already, please pause the video and go work on the activity so you can make these discoveries yourself. So pause this and go work on that, and then come back and we'll have a quick discussion about it. So jumping over here to this Desmos activity, we're going to first take a look at corresponding angles. And there's a special relationship between corresponding angles that are created by two parallel lines when they are intersected by a transversal. So you'll see this line this line right here, we'll color it orange. So the orange lines here are parallel. Okay, I'm telling you that. And they are intersected by a blue transversal. So here we have an example of corresponding angles. The corresponding angles here would be G and E because they are on the same side of the transversal but on opposite sides of the parallel lines. So another example of corresponding angles could be angle, if we look at these options, angle D and F. because angle D and F, they are on the same side. Make that green. So angle D and angle F are on the same side of the transversal, but on opposite sides of the parallel lines. So that would be an example. Angle A and C would be examples of corresponding sides, because again, angle A is on the, make these orange, angle A is on the same side of the transversals as angle C, but they're on opposite sides of the parallel lines. One's on the outside and one's on the inside. Okay. And then finally, H and B, angle H and B, those would be corresponding sides, or my fault, corresponding angles. So make those purple. I'm not sure why that text box keeps popping up. Okay, so those are the corresponding angles in this example. Now what we're going to do is we're going to come to the next slide and we're going to take a look at what do you notice about corresponding angles. So I have one pair of corresponding angles highlighted in red here. And if we were to look at these, so that angle would be, make it green, we'll make this one green. So I've highlighted some corresponding angles here. So what do you notice about these corresponding angles? The answer should be, you should notice that they are congruent. And it doesn't matter where the line is, where it intersects the two parallel lines, and it doesn't matter what angles they create. What you'll notice is that the red angles, they are corresponding, and the green angles, they are corresponding. And what you notice about the measurements is their measurements are congruent. The green angles are both 102, the red angles are both 78 degrees. So what we can say is, if we come back over here, we can make a conjecture about corresponding angles. And what we would say is, if two parallel lines are cut by a transversal, then corresponding angles are congruent. So anytime that you have corresponding angles, they are congruent. The next type of angle we talked about were alternate interior angles. So we're going to come back to the Desmos activity, and we're going to look at alternate, I guess on the Desmos activity I have alternate exterior angles first, so we'll take a look at those. So angle A and angle B, those are alternate exterior angles because they are on opposite sides of the transversal, and they are both outside of the parallel lines. They're not on they're not in between the two parallel lines. So the other alternate exterior angles in this picture would be angle D and angle E, because angle D is on the opposite side of the transversal as E, and they are both on the outside of the exterior of the parallel lines. They're not in between the two parallel lines. So if we go over here and start looking at the relationship between alternate exterior angles, you should notice the same type of thing. You'll see the two angles highlighted in orange. Those are alternate exterior angles. Now if I start moving the parallel lines to create different angles, you'll notice that the orange angles are both 73 degrees. You'll notice that both the orange angles are 39 degrees. It doesn't matter what angle is created with the alternate or with the parallel lines and the transversal. Those two alternate exterior angles are always equal. So let's jump back over here. We'll make, we are going to do this alternate exterior angle conjecture first. So again, it says if two parallel lines are cut by a transversal, then alternate exterior angles are congruent. Okay. So then the last thing we want to look at is what happens when we have alternate interior angles. So again, if you look at this picture, we have a pair of alternate interior angles, G and F, the ones that are red it looks like. So G and F are alternate interior angles. They are on the opposite side of the transversal, but they are both on the interior, the inside of the parallel lines. They're in between the two parallel lines. So the other pair of alternate interior angles would be H and E. So oh, nope, I made a mistake. It would be H and C. So H and C. Okay, I'm not going to worry about highlighting it. You can see where C is. So H and C are our alternate interior angles because H and C are on opposite sides of the transversal, but both on the inside of the parallel lines. So again, if we come over here, we will look at the alternate interior angles. We have this one right here, and this angle right there. Those are the alternate interior angles we'll look at. You'll notice that they're both 55 degrees here. And then if I move the transversal, they stay 55 degrees. And if I start moving the lines, you'll notice that the green angles that are alternate interior angles are congruent, 28 and 28, 62 and 62, 123 and 123. But regardless of where the angles are and how they're created with the transversal and the parallel lines, you'll notice that the alternate interior angles are congruent. So we'll come back over here. Our conjecture for that is if two parallel lines are cut by a transversal, then alternate interior angles are congruent. So we can combine these three conjectures and create one conjecture. Our one conjecture is called the parallel lines conjecture. So if two parallel lines are cut by a transversal, then corresponding angles are congruent. Alternate interior angles are congruent. And alternate exterior angles are congruent. Okay? Now, the last thing that we want to take a look at is, do these angles, corresponding angles, alternate interior angles, alternate exterior angles, does this conjecture hold true if we do not have parallel lines? So we'll come back over here and let's take a look at this. Here we have two lines that are not parallel that are cut by a transversal, and what I want you to notice is for corresponding angles, that 56 and this 71, those angles would be what we consider corresponding angles because they're on the same side of the transversal but on opposite sides of the parallel lines. One's on the outside, one's on the inside. 56, 71. Those are not congruent. If we look at alternate exterior angles, 124 and 109, those two angles would be alternate exterior angles. 124 is not equal to 109, so they are not congruent. And finally, alternate interior angles, 56 and 71. Again, those are not congruent. So to answer that question is, if you start with non-parallel lines, then this conjecture does not ring true. Okay, so no parallel lines means no congruent angles like above. Okay, so we're not going to go through this whole investigation. What you need to know is the converse of the parallel lines conjecture true? So what that means is, remember, a converse of a statement is where you switch the if and then parts of the conjecture. So what this would look like in this case would be for the converse. Let's see, do we have it written here? We do not. So the converse of this is right here, actually. If two lines are cut by a transversal to form pairs of congruent corresponding angles, congruent alternate angles, or congruent alternate interior angles, or congruent alternate exterior angles, then the lines are parallel. Okay? So again, what this is saying is, if you're looking at two lines that are cut by a transversal and you notice that the corresponding angles are congruent, the alternate interior angles are congruent, and the alternate exterior angles are congruent, then you can conclude that the lines are parallel. Okay? So you can read through this. We are not going to develop the proof ourselves like we have been. I have it written out for you here, so you can take a look at reading through that if you're interested in how we prove that conjecture is true, but we are not going to take time to do that right now. So that is the end of the notes. Again, the important thing that you should take away is that corresponding angles are congruent. Alternate interior and alternate exterior angles are congruent. One last thing that I want to do before we end the notes is I want to make sure we define corresponding angles, alternate interior angles, and alternate exterior angles. Corresponding angles are going to be angles that are, here's how you can remember it. My fault. Corresponding angles are going to be angles that are same side of transversal / opposite sides of parallel lines. And what that means is one of them is an interior angle, one of them is an exterior angle. Alternate interior angles are going to be opposite sides of transversal and interior of the parallel lines. So in between parallel lines. Finally, alternate exterior is going to be opposite sides of transversal, opposite sides of transversal / they're not in between the parallel lines, they are outside. Again, that's why they're called exterior, outside of parallel lines. All right. So that is the main idea of these notes. When you're working on your homework, you should feel comfortable identifying which angles in a picture are congruent and using that information to find the measurements of missing angles. So if you have any questions, email me or message me on Remind and I will answer them.